Howdy PreCal, it is Miss Kosh, and this is the third video I'm making for the very first unit of our year, very first notes of our years. 1A is functions. Okay, so go watch the previous videos. I'll assume that you have. And here we go. So this right here is what we call a piecewise function, because you'll notice it is made up of different pieces of the graph. And so the first thing, and I think they're telling us this graph is f. Okay. So f of 0. So when I look over here, when I have an x value of 0, what's my y value? It sure looks like -2. I hope you agree with me. A lot of these, if it's not exact, I probably intended it to be if I wrote the problem. Okay, so the next one, f of 2. So when we look over here at 2, we notice that there's something happening down here, and there's something happening up here. And they probably, I may have written this problem years ago, and now I see it again. I don't know, maybe I didn't. But this, if they don't indicate a circle, we can assume that it's a closed circle. If we want it to be open, we got to draw it in. Okay, and so when our x value is 2, our y value can't be this down here at -2. Oh. It can't be this one, that's no good. What it's going to be, it's the one up above it where it is a closed circle, and so this is equal to 1. Okay, so the domain. What I see is that we start with an x value of -3. We cruise along, everything's great. We have some discontinuity. It's not continuous here at 2. It's not defined down here, but it is defined here. So we can keep saying, okay, my domain started at -3 and it kept going. It got to 5 and then it stopped. Okay, so our domain, what did I just say? -3 to 5, and we include both -3 and +5. Okay, so our range, let's clear out this clutter. Go away. Our range is, okay, what are our y values that we're looking at? My pencil keeps dying. I don't know the story. Okay, so our y value, we start as low as -4. We keep going up. We have this gap from here to here. Do you see in this area? But it's defined over here, so we don't need to worry about that gap. So we're going to keep going, keep going, keep going, keep going. When we get to this at +4, I shouldn't have drawn an arrow. I should have just stopped it. So we get to +4, and then we're done. So we're going to go, our range is going to go from -4 to +4. Is it a function? Well, did it pass the vertical line test? Does it pass the vertical line test? Yes, it does. So if I take a vertical line, well, pretend that's vertical. It's really not. And then I drag it all around. Here you think, oh, well, it's open, an open circle and a closed circle, we're fine. So everywhere it just hit in one spot. So, well, go away. There we go. Okay, and there we go. Is it a function? The answer is yes. All right. The next one, oh, they want us to graph a piecewise function. Okay, so on this one, the first piece is valid when x is less than -1. So what I would do is I would plug in -1 and see what we get. But we're going to have an open circle. So we're going to have an open circle at the point -1, and then when I plug in -1, I have 2 times -1 plus 5. 2 times -1 is -2, plus 5 is +3. So I need an open circle at -1, 3. -1, 1, 2, 3. And then so I have a few ways to approach this problem. I could then plug in another point, or I could say, and I could plug in lots of points. It's going to go to -infinity. Or I could recognize, well, that's a line with a slope of 2, but I want things that are smaller than -1. So instead of going, a slope of 2 would be rise over run, rise 1, 2 over 1, rise over run, etc. I don't want any of those points that I just drew, because these points are going to be bigger than -1. So I'm going to do the opposite. Instead of going rise over run, like rise up to run 1, I'm going to go down to back 1, down to back 1. So I'm doing a negative and a negative, so that gives me, because a negative divided by a negative is a positive. And so I've got a bunch of these points. Pretend I can draw a straight line. I'm going to put an arrow and keep going. Did I do it right? Well, close enough. Okay, the next one, then from -1 to 2, I have a graph of just a horizontal line, y equals -2. So what that's going to mean is I'm going to have the point, I'm going to have a closed circle at, when I plug in -1, I'm going to get -2. And then I'm going to have an open circle that ends that line at 2, because notice it's not equal right here. It's just less than, and so it's going to be 2, -2. We'll have an open circle. So at -1, -2, I have a closed circle. Make it obvious that it's closed, if you don't mind. And then we're going to have an open circle, 1, 2, -2. And this is just this lovely little line that cruises between them, because that's that horizontal line at -2. Okay, the next one, what I would do is, well, so it's just going from 2 to 3. Okay, so let's plug in 2 squared. And on this one, so a minute ago I made a big point of putting parentheses. Well, it doesn't matter quite so much if it's positive. The notation looks good, but okay, so when I plug in 2, I get 4 minus 3, which is equal to 1. Okay, so I'm going to have a closed circle at 2, comma, what did I just get? 1. And I'm also going to have, okay, so when I plug in 3 squared minus 3 squared is 9, minus 3 is equal to 6. I'm also going to have a closed circle at the x value of 3. I would get a y value of 6. So those are closed circles. Let's see. So I have a 2, 1 is a closed circle. And then I have a 3, 1, 2, 3, and then 6, 1, 2. Okay, let's see if I can not get lost in the weeds. 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, and now this is me being picky. This is a parabola. And so we don't draw parabolas like that. That's an absolute value. They're kind of curved. Well, we're just looking at this one little piece of it. So it's a subtle curve, but it should be a curve. So try and come over here and show me a tiny bit. Okay, not perfect, but if you can do as good as that, then I'll call it good, because we didn't have a lot of space to show the curve. So anyway, there we go. Now let's look and see what they ask. F of 2, we can look at the graph here. And notice f of 2 would give us these two values perhaps, but we just want the one at the closed circle, and so that's equal to +1. F of 3 is going to be the other end of that. Well, we just saw that f of 3 gave us this 6 right here. F of x equals -1. Okay, so that means I want to use an equation y equals -1, and it crossed. Pretend I can draw a straight line. That's kind of terrible, but it's supposed to cross right here, which is x equals -1 to -3. X equals -3, and it was easier for me to see that from the graph, because technically if we just look at the equation, we don't know which piece hits -3. So I have to set 2x plus 5 equal to -3. When I do, I get 2x equals -8, and I get x, wait, did I do something wrong? Yes, I changed the problem. Did you notice this? It was a f of x equals -1, but then I decided to go with -3. Well, that's just wrong. Did you catch my mistake before I did? If so, good job. It was -1. When I subtract 5, I get -6. When I divide by 2, I get -3. And so I would get that. And then I would say, okay, well, the next piece, -2, can't be equal to -1. So that piece is never going to hit. So what we're looking at here is that this piece over here can never hit that line. Okay. The other thing, and then you'd have to look at, so this is piece number 1, this is piece number 2, and you'd have to look at piece number 3, which would say x squared minus 3 is equal to -1. All right, so we get x squared is equal to, add 3 to this, we get 2. Well, which means that x would equal, actually I have a cheer for this that I'll teach you later, plus or minus √2. But this is more complicated. What happens here is the graph is coming down and it hits this down here somewhere, but it's not the piece that we want. So this was when we used piece 3, excuse me, when x was when x was on the interval from 2 to 3. Well, hopefully, maybe you know the square root of 2 is equal to the square root of 4, and 3 is equal to the square root of 9. And if we're looking at that, here, let me do it this way. On my number line, I have the square root of 2, the square root of 4, and the square root of 9. And we have to live inside this world, and so this piece right here is not inside that world. Okay, well, that was a little ridiculous. So it was only this answer, and the graph helped us more than all this other ridiculous stuff I just did. The domain, we have negative infinity, and then we have this jump, and then we stop, though, at 3. So the domain goes from negative infinity. We have some discontinuity, but my x is defined everywhere until 3. So then we'll do the hard bracket. My range, I go all the way down to negative infinity because of that arrow. And then I come up, and I see that I've got like a jump, but this piece is defined over here. So the highest that we ever get is we get to 6. We include 6, and then we're done. All right, I think that's the end of our first day of notes. So like, subscribe, comment down below. Let me know how I can help you. And the only way to learn math is to practice. So go practice.